that's the starting point of any discussion about semiotic intelligence, because this is a very big shift of paradigm. So you leave the idea of connectionism, of channel information being processed by those mechanisms, and now you enter into the realm of feelings, the realm of qualities, of qualisigns, and this is where semiosis is being developed. And this is the crucial point. Are we ever be able to produce a system that will process information as it feels information? I don't know. What I can say is that the kind of hardware that we are using nowadays is not able to do that.
Hello, fellow sound lovers. I had the great pleasure to talk with Vinicius Romanini again, a magnificent semiotician and the professor of communication studies at the University of Sao Paulo. We spoke about AI, the nature of consciousness, and how emotion is a fundamental aspect of cognition and consciousness. Remember to follow me on Substack and on Twitter. The links are in the description below. But without further ado, here is the conversation. I hope you enjoyed as much as I did.
Yeah, okay, the main question I want to ask is, can AI become conscious? You know, that's the big question everybody's thinking about.
Yeah, well, I cannot say that I have an answer for that.
Yeah, but we have an interesting perspective on that.
What I can say is that if we are to talk about real intelligence, real artificial intelligence, at some point we would to tackle the idea of consciousness. So what we have now is not intelligence in a semiotic sense. It might be intelligence in a very strict, very narrow sense that takes the idea of intelligence from the theory of information and the connectionist paradigm of intelligence. But if we want to discuss intelligence at large, full-fledged intelligence or semiotic intelligence, then certainly something like consciousness will have to be involved. I don't know if we will ever be able to do that in our computers. Maybe not. I don't think that the kind of hardware that we have today will ever lead us to consciousness, to the simulation of a conscious process. It would have to be a different kind of hardware, a different kind of structure of material, and maybe our technology is not so advanced on that matter as we would like to.
Yeah, because that is one question I was thinking about. I found this quite interesting quote by Max Tegmark, a physicist and cosmologist, who's written about AI. Yeah, so he has this quote: "I think that consciousness is the way information feels when being processed in a certain complex ways." And I think this is a good quote. It has a lot of things that we could elaborate, but you brought up this idea that consciousness has to be embodied in some way.
Yeah. Well, the idea of feeling is crucial because nowadays we cannot say our computers feel anything. They don't feel anything. They don't have feelings. So they don't feel the information. And that's the difference between a living system and a mere connections of hardware. A living thing, even a bacteria, a microorganism, is capable of some degree of feeling, and the intelligence that emerges from this processing of information through feelings is what we may call consciousness, and that what I think would lead us to semiotic intelligence. So this is the crucial point, because nowadays the paradigm is very materialist, physicalist, connectionist. So they think that feelings, qualities of feelings, are second intentions. Somehow we have this epiphenomenon that we cannot explain yet, but sometime we will be able to explain. Maybe consciousness is just a bad word, like Daniel Dennett is always emphasizing. There's no such thing as consciousness. This is bad psychology, folk psychology. We should get rid of this word, because this word doesn't mean anything. And actually, at some point, we'll be able to understand how our brains are able to produce these emergent phenomena of second intentions, colors, shapes, tastes, and everything else. Well, from the semiotic point of view, we have to think not on the problem of brains, but on the problem of mind. So semiotic, it's about logic. It's about mind. So when we talk about semiotic intelligence, the perspective is taking mind as the crucial point to be studied, and not the brain, synapses, connections through neurons. So that's the paradigm shift that a semiotician should be able to do. Is there anything to be learned about the connectionist paradigm? Yes, there's a lot to be learned. They are doing wonderful stuff. But they are not being able to understand what's going on, because they have the wrong meta concepts. They have the wrong approach. They don't have the mindset that is sufficiently developed and deep to understand what's going on when they are trying to simulate artificial intelligence. And I think that's the contribution that a semiotician should be able to do when he sees the same things that a connectionist sees, but interprets in another fashion, in another way. And the way that we should interpret is to look for qualities of feelings. The feeling of information are something fundamental, something that is the basis of any intelligent process, any conscious process. And if we will ever be able to emulate or simulate intelligence, the basis of the system should be feelings. So we have this plethora of feelings which are iconic, quality signs, and through a logical process, this plethora of quality signs, they cancel each other, so that at some point we get a single feeling. So instead of having a taste as a epiphenomenon of information processing, we must understand a taste as a point of convergence of multiple lines of possible semiosis that cancel each other in a very similar way in which Richard Feynman defined the path integral of possibilities or probabilities. So we know that a particle is like a wave of probabilities, and those waves of probabilities, they can cancel each other, and at some point you have a definite probability of a quantum particle being at one state or another, or at one position or on another. And I think feelings are pretty much the same. We start with the quality signs, which are all possible feelings, and somehow intelligent conscious systems are able to cancel all these possibilities and get to one particular feeling or a habit of feeling or a quality of feeling. I think this is the big point. This is the basics of any, that's the starting point of any discussion about semiotic intelligence, because this is a very big shift of paradigm. So you leave the idea of connectionism, of channel information being processed by those mechanisms, and now you enter into the realm of feelings, the realm of qualities, of quality signs, and this is where semiosis is being developed. And this is the crucial point. Are we ever be able to produce a system that will process information as it feels information? I don't know. What I can say is that the kind of hardware that we are using nowadays is not able to do that. So we'll have to think about some other possibilities that maybe are not being considered.
Yeah, that was one thing about semiotics that was very intriguing for me, was that feeling is a type of interpretation. It's part of the semiotic. So the semiotic or semiotics, even though it's a logic, but it's not it's not the kind of logic that we normally think what logic means. Feelings are logic, are part of logic as well.
Yes, it is part of logic. Feelings, actually, Peirce's idea is that we need a logical sentimentalism. And this logical sentimentalism is based on the idea that feelings generalize into sentiments. So I have a strong feeling about something, and this is very particular. But when I discuss, when I communicate my strong feelings, they become less strong, more diffused, more amenable, and then more connected to endurable sentiments. So that's how we usually produce knowledge out of feelings. Feelings in themselves are felt in a very strong and particular way, but when they develop and generalize, they become logical sentiments that produce a sort of knowledge that is fundamental to our evolution, to our the ways we develop societies, communities. So this is the ground, the basis of communication, as we share our sentiments into something that is greater than our private feelings.
Yeah, and this is also, I think, very different from the usual way to see. Yeah. But I'm speaking about the first steps of perception that we have. I think that the main view is still that we perceive particulars, or singular things, bits of information, and then we form this concept. Our mind forms this concept. But you're saying, and Peircean view is that we feel this oneness, this buzzing quality, this kind of a cloud of possibility, and then something actualizes, or we have the ability to, as you said it, cancel these possibilities, or how did you put it? But then something particular becomes actualized in our experience, and then later through this logical process we experience particulars, and then we put them back together and generalize them again. So it's like it starts from a very general kind of oneness, goes through a particular phase or particularity, and then gets welded again as a general thing to the universe. So these are the categories basically, but it's a very different kind of idea of this process.
That's interpretation of Kant.
Exactly. Yes.
Because the idea that a proposition is nothing else than we perceive the predicate or the iconic connections of qualities, and we perceive them as a whole. That's firstness. But at some point, our attention is directed to a substance. When our attention is directed to a substance, we have denotation, and the indexical part of semiosis emerges. So the indexes comes up when we denote things in this pure world of possibilities. That's a universe of possibilities. Notation picks up some substance. And then you have what we have picked up is the subject. Everything that is out and was not picked up is the predicate. So the predicate is the sort of diffuse firstness that involves the substance of our object or the subject. And that's how a proposition is born. A proposition is nothing else than picking up a substance that is the target of our denotation and leaving out everything else, which will become the predicate. And he describes this is in his first article, how the category, the new list of categories, when he talks about the oven is black or the stove is black, and he's saying, well, out of this complete, the phenomenon, which has everything in my immediate perception, I pick up the stove as a substance of my attention, and by picking up it, I denote the substance as being the stove, and I eliminate part of the confusion of the predicate by selecting blackness as a attribute, as a general abstract attribute of this substance. And by doing so, I transform something that was very confusing in my first immediate impressions into something that is knowledgeable, something that can be is part of my knowledge, because now I know there is a black stove in the environment. So this becomes internalized as information, semiotic information. But I had to feel this. This is a process that is based on feeling, and that's why intelligence. When we talk about semiotic intelligence, we're always sometimes in a simpler way, sometimes in a more complex way, but we're always describing this same process of producing propositions, producing assertions that ultimately are our beliefs about the world. So we do not start our process of knowing things from a tabula rasa, from nothingness, but we start through a model, a generative model, which are all the prejudices that we carry on before we pay attention to anything. So we have a set of beliefs. Some of them are learned through culture. Some of them are inherited through evolution. So we have lots of habits, mental habits, that we inherit in a very long, millions of years of evolution, so that we can have this generative model of our possible perceptions, of our possible denotations, and that's what is specific to each single species. The biosemioticians call this the umwelt. Right? The umwelt is this like a bubble of possible meanings that is part of the constitution of a species. It is a species specific. Now, this generative model, this umwelt, we come into our lives. We are born in nature already, bringing along with us this umwelt. We carry on the umwelt that was generated in thousands of generations that define what we call being humans. So this generative model is a set of possibilities. And this is where the iconic quality of feelings live. They are this wholeness of all possibilities of sign production that are part of our umwelt. And when you or me, when we are paying attention through our perceiving apparatus, we are paying attention to some objects, we are actualizing possibilities that are already there as real possibilities in this generative model that we call umwelt. So we cannot perceive what we cannot interpret. And that's not Vinicius saying, this is Peirce's words. We can perceive only what we are capable of interpreting. Why so? That's Peirce's. I can give you that. So we are able to perceive in the world all those possibilities that are previously given by our umwelt, or this density of possibilities that are part of our constitution, the mind.
Yeah, but some new information comes through perception, right? Still, we do we you know, it is not set in stone what we can perceive, right?
Well, at some point, what we do, we enlarge the possibilities of our perceptions. Like when we find out how a microscope works or a telescope, or so all mediums of communications are extensions of our perceptive apparatus. This is McLuhan. So McLuhan says that our communications channels, the medium, they are nothing but extensions of possibilities of perceiving. So that's part of our intelligence. We are always searching new possibilities of internalizing information. And through scientific knowledge, we are developing new tools of enlarging those possibilities. But I would say that we are largely determined by a set of possibilities that are given by our structural, the set of relations that make our system, our knowing system. So we cannot see things in the world that our perception cannot individualize. So there's a limit. We are not godlike beings. We cannot know everything, because there's a limit to what we can actually know, and this limit is given by these possibilities of the umwelt.
Yeah. No, this reminds me of what Jesus said, that no one has seen the Father.
Exactly. I mean, that's why Peirce says, well, where's truth? This little word that we love to say, truth. Well, truth is a normative ideal. No single human is able ever to say with absolute sureness that I have the truth. No one of us can say with absolute certainty that he has the truth. Not a whole community and not the whole human species, because the truth is a normative ideal, is something that would be attained by an ideal mind with ideal resources, with ideal time, and we would to have to put together all possible minds in those minds that are living now, those who have lived, those who will live in the future, those minds which are humans, not humans, those minds that are living in some parts of the universe that we know nothing about. I mean, truth is not something that a single or a numerable quantity of minds can have as a certainty. It's something that we search, we try to approximate, but we should be humble and from the starting point, knowing that we will never be able to get our hands into this very slippery word of truth.
Yeah. So we are speaking about the immediate qualities of perception pretty much right now. You know, what we can even perceive. And now to bring this back to AI, these systems do not perceive. They don't have sensations about the environment. So it's a very different, I hesitate, they don't have an Umwelt in the same sense that a biological organism has.
Yes, if they did, they would have personality. So you'd turn your computer on and he would say something like, "Oh, I'm tired today. I'm not feeling like working for you." So I'm kidding, but you're getting the sense. So when something has a feeling, it has a dynamic relation with the world, and it has some sort of purposiveness into this dynamic relation, and it is able to make its own mind. And that's the crucial point. Is your computer making its own mind? Is the artificial intelligence, the way that's being described, is it making its own mind? Because being able to make its own mind, that means making mistakes. Because when something makes its own mind, usually it's full of prejudices, it's full of strong feelings about the world, and is making mistakes all the time. That's what makes us humans and not machines. We are making mistakes, we are regretting, we are feeling sorry, we are feeling happy. So do we want our computers to have this mood and say, well, I'm too tired to work today? So, but at some point, if we want real intelligence, we have to tackle these questions. What kind of independence or arbitrariness we want our systems to have, so that they can decide by themselves if they want to help us and why they would like to help us and what they get from helping us. And so what sort of gain so I gain something, you gain something. So what kind of game do we want to play with those intelligent machines? Because if we take our kids, so our 3 years old kid, it's a very smart, very intelligent. We are negotiating with it all the time. So we want our computers to be able to negotiate with us what they want to do or not want to do.
Yeah, that sounds like a lot of work. A lot of work. But what I'm, so am I right saying that you are very skeptical of AI ever reaching, if you speak about AGI, artificial general intelligence, which is, nobody really knows what that even means precisely, but to say that that is some kind of maybe sentient being, have some kind of consciousness. So you are very skeptical that AGI is possible without some kind of hardware that can sense and feel and perceive. Would that be right?
Yes, but maybe,
Okay.
that's a big maybe.
Okay.
Maybe we can simulate those processes as well. And that's why I'm studying protein folding. Proteins are able to fold, they have their native shape, and they're able to fold and get to their shapes in less than a second in a way that is not randomic search. So they're not uh, calculating all possibilities because that would take an almost infinite amount of time for them to do. And at some point, they fold and they get to their native shapes in less than a second. So what are they doing? That's the question. What are a single protein doing? Because maybe the core of intelligent behavior is right there are in those kind of processes.
Yeah.
Because we know that proteins, they are connected to larger structures, and the laws of natures are playing an important role in what they are doing. So there are habits, mental habits that are not in their fine structure, chemical structure, mental habits that are the laws of natures. And in some sense, they are processing feelings and information, learning from those mental habits that are universal, and they are getting to their shapes in a very precise and quick way, very smart, which I think it's very smart. And this kind of process cannot be described by any of our current systems. So when you say, well, but there is a program that can study the way proteins fold and guess in a very precise way how a certain number of chemical connections can fold. Well, the computers that do that, they are huge. They use a lot of computation, a lot of energy. They cost millions and millions of dollars to figure out what a single protein might do. And they get 80 to 90% of things correct.
Yeah.
But those proteins, they don't have the supercomputers of IBM. They don't have all the power of
Intel
electric
processors,
Yeah, they just do it.
Yeah.
And the amount of energy they use is almost nothing.
Yeah.
So you see where I'm getting at. So if we can build a system that can prove theorems using protein folding. So you pick up a single theorem. Well, I want to build a system that will prove this very simple theorem using protein folding. The folding of the protein will give the answer to this single problem. Now, this would be a game change.
Yes.
Because then we have opened a new door, a new universe.
Okay, so I have a question now. Okay, you were speaking about the studying the unfolding of proteins. Now, could that be conceptualized as computing? Are the proteins computing?
Sure. No, absolutely.
Yeah.
Totally.
Okay.
It is a sort of computation, but it is a analogic computation. It's not a digital computation.
Okay, can you elaborate on that?
So maybe analogic computation is able to internalize qualities of feelings that the digital computation, as we have nowadays, is not able to. This is hypothesis. It's not something that
Yeah.
But
Yeah, we're being fallibilistic.
yeah, I think that's something that we should inquire on. I think the way proteins fold, it's certainly very analogic, and it's closer to the way living beings process information. So the semiotic process of information is continuous, it's not discrete.
Yeah.
So the idea of continuity is fundamental to the semiotic information. And the folding of proteins is a continuous process. So a protein does not fold by discrete steps. It just folds as a whole in a very continuous manner, which we call analogic. And I think that the consciousness of or the qualities of feelings associated with purpose or quasi purpose, they work in a very similar way.
Yeah, so okay, so AGI should be an analog or analogical computer.
The basis,
if that makes sense.
the analogic. You know why? Because vagueness is crucial.
Yeah.
Vagueness, and digital information does not allow vagueness. It considers vagueness as a computer. When it faces vagueness, it goes into tilt, into looping. It cannot hold vagueness.
Yeah.
But every single intelligent living thing could be a microorganism, or it's always dealing with vagueness in the sense of there are a continuous variation of concentration of qualities. So like a bacteria, it would capture through its senses continuous changes in some chemical density in the environment. So it's always a computation through continuous and vague processes. And I think this is fundamental to real artificial intelligence, being able to cope with the vagueness of the universe. The universe is a vague structure.
Yeah.
And computers do not allow vagueness into their computation.
Yeah, but you don't have any problem saying that consciousness is computation.
Well, we can say that it's computation, but then you have to define what you mean by computation.
Yeah, well, what would you mean?
That's the crucial point, because if you talk to an engineer that comes from it's Shannon and cybernetic paradigm, he has a very precise idea of what computation is.
Yeah, but we're not speaking about bits, right? We're not speaking about ones and zeros, about discrete bits of information. We are talking about continuous qualities. Earlier we were speaking about our perception, how we perceive qualities and how we feel information. My question is that computation? Would you consider that or conceptualize that as computation? It is, but it's a different kind of computation compared to computers.
Yes.
But it's still some kind of computation.
Yeah, but then we have to rephrase or at least define what computation is, in which sense we mean computation.
Yeah.
Now, computation is when there is something that is coming into the system. We call it information. So the system is gathering information from the environment and is using a model, a generative model, a set of beliefs, so it's prejudices. You can define it as you want, but there is a mental state. There is a collection of beliefs about how the world works. So the information is coming. Those beliefs are interpreting those information are consequences of the world as it is represented through the generative model, and is giving back to the environment an output, which can be an action or which can be a change of its own mental state or its own beliefs. So if we define computation in this sense, gathering information through the world, trying to interpret those information based on the repertoire of our set of beliefs, which is a generative model of what we believe the world is outside of minds, and then giving to the world or a output, a resulting information, which can be either a change in the world. So I go to the world and change it so that my expectation of what those impressions should be is fulfilled. So I act in the world. And this is a sort of output.
Yeah.
Through this semiotic computation, I act, I produce dynamic interpretants in the world. Or else, I change the set of relations in my mind, and this is a dynamic interpretant that changes how my set of beliefs is organized. So the output can be either a change in the way I believe things in the world work, or can be an act in the world. So I change the world in a way to make the world more similar to my representation. And this is what culture is. Yeah. This is what civilization is. So civilization is nothing else than changing the environment around us. So what we think the world should be is instantiated. So we bring about things in the world. We create things in the world. So the world, the environment around us, can represent an ideal of how the world should be. So culture is computation.
Yeah.
If we take every human beings that are acting together in what we call humanity, mankind. So we are doing a collective computation because we're gathering information from the environment, and we are either producing knowledge about how the environment works, and this is facing our previous beliefs, or we are changing the environment so the environment becomes what we think it should be. You see? Yeah. So the production of scientific knowledge and the changing of the environment are the two possible outcomes of our computation or semiotic computation of information. Now, do computers can do that? I don't think so. Not in the way that I have described. Not in the way that I have described.
Yeah, they don't have a real dynamical relationship with the environment, in a sense.
Well, some scientists now say, those who work with our algorithms, machine learning, generative models, they say that nowadays the algorithms, they are very flexible, plastic, and they can change themselves in a non-supervised way. So they will do this process of changing their internal relations and remaking themselves. And I think this is a step forward towards what I'm describing as semiotic intelligence. But what is missing? Missing is feeling.
Yeah.
So if they would do that in a way that they would feel the information and consciously with some sort of purpose or quasi-purpose, they would decide, they would make choices based on their qualities of feelings, then we would have real artificial intelligence, but then we would have very, very dangerous machines, because those machines would be able, like the movies, right? Do you remember how the computer that talked to the human, and they were having those philosophical conversations? And so do we want that? That's something that we have to think about it. If we want machines that are very very efficient in gathering information and processing those informations in a more auto-sufficient way.
Yeah, well, I was thinking about that. They don't have a sort of, rich dynamic relationship with the environment. You know, algorithms, the GPT, they are processing symbolic information. They are processing language, as as I know it. So it's a very different kind of environment which they are living, so to say. They don't have this kind of a very fundamental, perception or experience, or this experience of being part of reality and the habits of the environment that we have. That was the idea that I had. That it's very different, and this is missing. So I was thinking about, we process information in order to establish habits and beliefs that would be efficient, that would be pragmatic. But how would AI that processes only symbolic information form a habit or a belief that would be comparable to our beliefs in that sense? And Peirce says this in his pragmatic maxim, that what some concept means are the pragmatic results. How would our AI experience those pragmatic results of some concept if they have no capability of sensing or feeling reality?
Exactly, because when what you said about symbolic information is correct, but when we talk about symbols, they do have a iconic component, which I call the predicate, and an indexical component, which it is comprehension and extension. The predicate and the subject or the object. So the point is, the comprehension of a computer is pre-established by the programmer, or by the set of the training set. So you train the algorithm through a very definite number of particular situations, and you through the capturing of those patterns, the computation can go on. But real symbols, they have this iconic part, which are metaphoric. So if computers could dream, if they could make real metaphors, not those sometimes we say, well, this computer can do poems, can write poems or can write music, and it's a poet. No, because it doesn't feel a real poet, a real poem is it's full of feelings, human feelings. It is full of metaphors about what meaning is.
So and it's not a linguistic metaphor. It's something deeper.
No, it's deeper. It's a living metaphors.
Yeah,
it's a cognitive metaphors. So we are always in our every situation we are bringing metaphors, dreaming in daytime, awakening. We're always connecting things and making those metaphors about what we are experiencing. And maybe we lose our minds because we got drift by those metaphors. So now we're daydreaming. So this is part of being intelligent, is being able to generate new possibilities of meanings through metaphors. And this is a very unstable process. So do we want computers to have this? And that comes back to my first point. They would have to have a mood, a personality.
Yeah.
They would have to, well, today I'm a little depressed. I'm thinking about life and the world and the universe and God. So I don't feel like doing all those tasks that you are proposing me. So being able to produce symbolic metaphors is having this inner life full of dreams, of qualities, of feelings, and connected with new meanings, very original, maybe disruptive meanings.
Yeah.
And that's not what a computer do. And maybe that's not what we want a computer to do. So when we talk about real artificial intelligence, we would like to have a system that would be able to do that, maybe in a controlled way, in a way that we can control the level of liberty, of production of meanings and metaphors. Is it possible? I don't know, because once you let a system do something like dreaming or producing metaphors, I don't know how much you can control the process, because metaphors, by definition, are not controllable. You cannot control what sort of metaphor something is doing in its inner thoughts. So that's very challenging. That's a philosophical question, actually.
Yeah, and these metaphors, they require an inner world. And you would say that computers don't have an inner world, although they have a model or a neural network that they process.
They have a model that is predetermined.
Yes.
It is a diagram of connections, of probability densities, and it works out very well, but it's not an inner world. It's not something that is, because it is not being felt.
Yes, there is no qualities in a sense in that model.
You see, we go around and come to and go always back to the same point: qualities and feelings. So Max Tegmark, when he says, "Well, information is how a system, intelligence is, or consciousness is how a system feels information." And that's the tricky word. Can our current systems feel information? We know, well, I know I can feel information. I see something and it disagrees me, and I want to change the world. But do we see computers, do they want to change the world? They are activists and they have their own agenda. And you see what I mean?
Yeah, I see. Yeah, Would you say though that computers reason?
Oh yes, yes, that's for
But
sure. Because reasoning,
is it limited reason? Because there have been some people are speaking about
machines can reason. That's plain. I mean,
yeah, but is it only but the question is it only deductive reasoning? But are they capable of abductive or
no,
inductive
I think
reasoning?
the algorithms that
Yeah.
we have today, they are pretty good at inductive reasoning because they can generalize from the training set. So they do definitely they do inductive reasoning. I believe the way they do inductive reasoning is very similar the way our minds process information. The thing gets more complicated when we ask, are they able to do abductive reasoning?
Yes.
Are they? I would say that some sort of abductive reasoning is already being accomplished. Some sort, because when we talk about abduction, there are many sorts of abductions.
Yes.
And when we talk about symbolic abductions, which are based on this distribution of patterns, those densities of probabilities that are distributed in the phase space of possibilities and so on, so on. I think today's algorithms, they can already perform some sorts of abductions. But do they perform those sorts of abductions that make us humans instead of machines?
Yeah.
No, that because those sort of abductions that are sensations that are part of the qualities of feelings that emerge in the process of experience. No, those sorts of abductions, I don't think computers can perform. And I don't think the way computers are built, the hardware they are built, can perform. If we were able to do computers in a way that proteins organize themselves, maybe we would put a step forward in the way abductions are performed. So a computer that would work in a similar way proteins work to fold and find their native forms or shapes. I think a computer working on those prerequisites would do many more types of abductions than a computer nowadays do. They would not be able to do all sorts of abductions, but I think it would be some steps in advance. They would do things that a computer nowadays are not able to do. And that would already be a huge paradigm shift.
Yeah.
We would enter into a whole new world, a world in which some sort of machines, we could say organic machines, they would able to perform logical inferences and make judgments and work with something that is close to metaphors, those shapes that percolate through the experience of nature. You see the difference? The forms that we internalize through this process, the Peirce defined as percolation, the laws of nature continuously, they enter into our collective minds and produce our symbolic representations.
Yes.
Not in me, in you, but in the collective mind. So maybe a computer based on proteins would be able to do that, even if it's not feeling and is not producing all sensations and abductions that a living, full-fledged living being is capable. But maybe it will be able to do things that are not imaginable with the current paradigm.
Yeah. So
that's my guess.
You wouldn't be concerned that our current AI that is working on a hardware with bits and zeros and ones can ever become conscious. That is not. Would you almost rule out that possibility? It cannot become conscious.
No,
bits,
I don't think so.
Yeah.
There is a theory which is becoming more popular. The idea of consciousness is integrated information. So this idea that the more complex the integration is, the larger the level of consciousness, which means that there is a little bit of consciousness in everything in the world. So a quantum particle has a minimum amount of consciousness. A computer has a little bit more of consciousness because it has a little bit more of integrated information. The whole internet, the World Wide Web, would have more integrated information. So in some sense, this collective process that we call internet has a degree of consciousness that is higher than our single computers. So it is an interesting hypothesis, but I still come to the same point as before. I think even if we could integrate all those informations, would it be able to feel?
Yeah.
Because at some point, they still think that feeling and qualities are second intentions. So they think that if you have information that is sufficiently voluminous and integrated, then feelings will come up. And then you have the feeling of colors and tastes and everything else.
Yeah.
But I'm thinking about the four phases in my head right now. And I think that this is the thing that we come back to in this conversation, that it's about qualities, it's about feeling, it's about emotion, sensation, sentiments, it's about concrete, embodied experience, the feeling of being in this moment. And these computers are dealing with symbolic information, symbolic signs that are very detached from anything resembling some kind of embodiment. And it's like the phase of sharing, in a sense, alone, without the basis, without the embodiment. Would that be a correct way to conceptualize it? Because would that be? It's not even a degenerate sign. It's something, I don't know what it is.
No, I don't think there is a phase like sharing, the phase of sharing without the others.
Yeah, exactly, because it always contains the more fundamental phase.
Yes. The thing is how rigid, closed, and dead are the others. Because when you have intelligent systems which are in the process of communication and sharing and self-organizing, so you see all periods are active, which means all phases are active, and one phase is bringing influence to the other. So there is a very effervescent change of states between the phases. So everything is pulsing, let's say. Like the whole, if we have the solenoid, the whole solenoid with all phases and periods, it's all pulsing and all alive. Now, when you have a computer, the symbolic is active. The symbolic is governing all the others, but the others are not contributing to the symbolic. So the symbolic is governing in a sense that is controlling It is the symbolic, which would be the program, or how the algorithm is written in which language, has its grips very strongly onto the other phases in a way that you don't see novelty, real novelty, because real novelty comes with feelings. So all phases and periods are being governed in a very tight and rigid way, and that's how computers work, and that's what a good computer program does. It has a good control on the system, and you know that if it loses the control, so there's something wrong going on. So we want the computer to be a system in which the software, the program, controls in a very efficient way everything that is going on below it in the levels that are more fundamental. When you have real intelligence, those things balance each other. Sometimes the feeling comes up and you don't have so much control of your feelings because you get very impulsive because something comes to your mind, or you see something that impacts on your feelings, and there are sensations being produced and metaphors being created, and there's no rational control on those processes, so there's no algorithm that's able to control what's going on. So at some point you lose your mind. But do we want computers to lose their minds? So a scientist, a poet, to be creative, sometimes it must lose its mind and see things in a very different way. It collapses, and then it gathers itself again. So this process might be very painful. You see how a poet suffers, how a scientist. Well, the computer is, it just does what the algorithm says it should do. So it's a very placid, very calm computation. So is it possible to think about intelligence and novelty and real production, original production out of a system which is so cold? So you see.
It would be odd that your laptop would go through some kind of a crisis in his life, some kind of aesthetic phase. Yeah, that would be odd. Speaking about the phases, how algorithms and computers are very rigid, very active in the symbolic phase. When thinking about our human experience, I think it's a certain kind of virtue to be active on all the phases all the time, that we don't lose touch with our environment or our perception, that we are in a sort of harmony throughout the phases in our everyday life, that we don't become so cold rationalist people, but we hold on to that emotional foundation or that qualitative foundation in our being. So I think that's a virtue that we should, be.
And we as individuals are particular beings. The phases which are the bottom are much more active than the phases that are on the top. So that's why we must live in community, because through communication, through sharing meaning, through symbols, we get this symbolic self-control that comes from society. More than our own pulses, because, well, this is very Freudian, the idea that we have these instinctive pulses that govern our individuals. So if we didn't have society, maybe our instincts would have their ways, and we would live in a very violent world in which the strongest always get what he wants. Now, society, and we call the law, the state, so all those, the religion and the school, all those social apparatus, they bring us some rules, some laws, some symbolic influence.
You were speaking about how we are not governed by our individual minds, but rather that we are governed by our culture, our civilization, our society, and our social systems.
And the laws of nature. Yeah. And the laws of nature.
And the laws, yeah, quite important.
Which comes with our Umwelt. So we have limited freedom to what we would like to think that we have lots of freedom of what to think and what to say and how to act. But actually, we do have lots of freedom. But at same time, there's a lot of constraints that are being imposed upon us. And many of those constraints, they are not even noticed. We're not even able to understand how they work in the way we think. So sometimes we think in a certain way, thinking that it's our own way of behaving, but actually, there's a lot of things that are determining the way that we behave in the environment.
I think that was it was circulating back to the qualities, the feelings. And I think that's a nice point, and that is something that is completely absent from the conversation at this time when I've been, following. Nobody's speaking about feelings. And I think that's an interesting point.
There are some people that, everyone is avoiding because they think that is going back in time into folk psychology. Oh no, we have discussed those things so many times already.
Those German poets are back again.
That would be an obstacle. Yeah, that would hold the research, and I think we should not go into this. It's going well, so we are making progress. So let's leave aside the idea or the problem of qualia, of feelings, of consciousness, and maybe when we have enough computation, enough power, we'll be able to simulate real conscious systems and etc. So I think it won't work out. I think it's not feasible.
Yeah, I think it was Sam Altman, the chief of OpenAI, was in Lex Fridman's podcast, and he said that I don't think that emotion is necessary for consciousness, and that sort of that was very unperceived view.
So this is very unsemiotic. It's a good quote because it allows us to understand how off track artificial intelligence research is. Because an emotion is a cognitive result of our experience. So emotion is fundamental. So someone, if it's not trained, if it doesn't know its emotion, we know how dangerous a person that doesn't know its own emotion, cannot treat its own emotion. It becomes a very dangerous person. The same thing with a intelligent machine. So an emotion is it is a cognitive result of experience, and it is a crucial one because it is sometimes the emotion in one single emotion you have many rational processes that are condensed, synthesized into one emotion. So instead of making a whole logical argument on something, you just have the emotion about that thing.
Yeah.
And so it is a shortcut. An emotion is a very important cognitive shortcut. So you can act in the world in a safer way. Because if we had to calculate and make all the inferences necessary, we would not be alive. Our species would not be a living species anymore. Yeah. That's how emotions work. It is a shortcut that allows us to act in the world in a safer way, in very precise and instantaneous way, so to prevent us from harm.
Yeah, but the synthesization of emotion is something different than compression of Shannon information. It's not the same thing, right? Because one of the researchers said that he thinks that consciousness is compression, that it is just a very capable machine of compressing, probably Shannon information, zeros and bits. It's a compressor compressing itself.
Well, an emotion, I would define emotion like, imagine that you have many metaphors that are superposed.
Yeah.
So it's a very complex predicate. So an emotion reduces the complexity of a predicate into a simple one. So instead of having to deal with many complex metaphors that are all connected and interconnected, you have one single emotion that is the resulting of all those metaphors. So this is very important because I wouldn't say it is compressing. I don't know if the word is compressing, but it is synthesizing.
It's a qualitative computation or qualitative process.
Yes, it is. Yeah,
so it's not about zeros and ones being compressed.
Analogic, continuous. Yes, because an emotion, it goes like that. So it starts and gradually it goes up to an apex and then goes down. So it is very analogic. You don't have an emotion as a discrete event. It is something that develops in time. So that's why, and what makes it amount? Well, the number of sensations, of metaphors that are involved in the emotion. So a strong emotion, it is an emotion that synthesizes a lot of sensations, complex sensations that you would not be able to individualize. So they're all put together in this emotional state. And an emotion, it is always giving you a readiness to action.
Yeah, it's not a combination of discrete quantities which make a strong emotion. It's more about the intensity. I really like this idea of an analog and digital, because it's a very powerful cognitive tool to think about the semiotics of Peirce, that it's fully analogical. It's not digital at all.
When we talk about analog, we talk about continuity.
Exactly. Yes.
In continuous increase, like a chemical gradient, so a concentration of a gradient. So it is a continuous. And that's why the artificial intelligence, that the machine learning is trying to do. They are trying to find the minimum gradient of error, of mistakes or surprise. So they're using the gradient descent. So in a certain sense, they are trying to emulate the analog of a continuous gradient descent into the avoidance of surprise or disappointment or mistakes or error. You can prediction error. I'm talking about those machine learning that are based on prediction error. So they are trying to emulate the idea of a concentration descent, but at the same point, they do this in a very discrete manner.
Yeah, it's a simulation, right?
Yes.
And simulation is also always something different than the real thing. So although they may be able to simulate perception, experience, and inner world, it's not the same as the inner world or the perception. So yeah, it's but yeah, and that has been my gut feeling with this AI stuff, that it is not conscious. It cannot become conscious.
And I think that semioticians, and that's why I was asking you to be part of this research when we started to work together, because I think that semioticians should be involved in the questions and the matters of artificial intelligence. And nowadays, I don't see so many semioticians being part of the teams, how they are thinking and contributing to those matters. Most of the time, I see semioticians being the critic voice. So they're criticizing what's going on, but in a very, let's say, from the above. I would like semioticians to go down and mingle with those people which are working with artificial intelligence and discuss this, because I think it's a very interesting area. And those topics are very important to semiotics. Yes. So we should be part of the teams that are trying to work out solutions. And I think we do have contributions. And we can make artificial intelligence advance in certain directions that maybe were not yet entertained or perceived by people who are working in the current paradigm of deep learning, machine learning, and so far, so on.
Yeah, I think so too. I think that Peirce has a lot to give. It's amazing legacy what he left for us. You know, just thinking about this AI stuff, what a rich gold mine all of this is. And I must give credit to your work as well. I think it should be. I think the work you've done in your PhD is something that is fundamental in order to be able to apply semiotics to artificial intelligence. You know, if you don't have the determinations between the aspects of the sign, if you're still having, you know, debates about, is it the dynamic object, is it the immediate object, what's going on, what Peirce meant here and here, you know, it's a mess. You know, it's not applicable. But after your work, it's applicable. But I don't know how many researchers are using your work here.
Yeah, I don't think so. I should my ideas and work out the way you can apply to your project. I think this is wonderful. I think that's how semioticians should work. I mean, I agree with you that the work that I have done in my PhD has a lot of potentialities that are still not all developed. There are many possibilities that can be developed from that work, and I'm trying to prove that. And it's part of my, let's say, my work. If I want to leave a legacy, I should be more clear about what are my conceptions on semiotics and how I see the classes of sines, the solenoid, and so on and so forth. But I think what you are doing, that interpreting my work in your own words and in the way that you see and understand it, it's equally important, because that's how a community works. Because by asking those questions, you always make me think or rethink on the subjects that I thought that were already closed, or subjects that I thought that were plain. But when someone asks a question, a different question, then you open the gates and you start to rethink things again. So this is a very productive in the way actually how scientific inquiry and semiotics should happen every day.